Hello, everybody, and welcome to the Gala webinar series. My name is Isabella Massardo, and I am the content strategist here at Gala. Gala is a non-profit trade association connecting and supporting the global language industry. Today, we have a webinar sponsored by Pangeanic, and the webinar is centered around deep adaptive in machine translation, closing the gap with human parity. Before we get to the presentation, I know that we are all expert in online events, etc. But just to be on the safe side, you are muted and you will remain so for the duration of the webinar. If you experience any difficulties, any technical difficulties, you can let me know by using your chat box, and I will work with you to troubleshoot them. If you have a slow internet connection, your audio may be disrupted. If that happens, you can use the number listed on the GoToWebinar panel, and you can call in using your phone. We are going to make a recording of this presentation. The recording will be published later on the Gala website. If you have any questions for our presenters, please type them in the chat feature or in the QA feature, and we will try to get as many questions as we have time for at the end of the presentation. Now, let me introduce you to the speakers today. We have Virginia Virino Hodar, Pangeanic Sales Director, Mercedes Garcia Martinez, Chief Research Scientist at Pangeanic, and Manuel Herranz, CEO and founder of Pangeanic. Other members of the Pangeanic team are present, and we have Amando Estela, Pangeanic CTO, Tokiharu Iwanaga, Business Development Manager based in Japan, and Brent Collins, Business Development Manager in the US. So, guys, the floor is yours. Please start.
Thank you, Isabella. Hello, good afternoon, and welcome, everyone. I'm very excited to be here today at this Gala webinar and introduce the next evolution in machine translation, and in particular, adaptive machine translation. I joined Pangeanic almost 1.5 years ago, in 2019, sorry. And I've been since how deep adaptive has evolved from concept on the drawing board and just a plan to something concrete and real. A technology that LSP, government agencies, and corporations are beginning to use worldwide. As the sales director and in the first person to have feedback from clients, I've been in sales and business development for more than 20 years in the medical, hospitality, and media sector. I've seen clients delighted with the service. But when it comes to technology, it really has to be something amazing to have positive feedback from users. And we do. LSPs in Spain, the UK, Japan, the US, companies that were part of our testing and becoming early adopters. Oh, I'm so sorry, 1 second. They have all become our best ambassadors because they have been cloning engines and specializing them with a specific material. We have walked a long way to make deep adaptive a reality, something that really works. And that comes real and integrated as a language technology. It really helps companies gain speed and automate processes. Well, it's the time. I would like to introduce Manuel Herranz, our CEO. He will describe Pangeanic's journey in the development of deep adaptive use cases and how deep adaptive works. It's your time, Manuel.
Thank you, Virginia. Well, I'm very happy to be here today and premiere deep adaptive to sister LSPs, translation companies in the world, and users of machine translation and developers of machine translation. For Pangeanic, this is a 10-year journey, really, that began back in 2009, 2010, when we were the first company in the world to make commercial use of statistical Moses system at the time, for which there was a lot of hype and there was a lot of expectation, and it certainly provided a huge leap in perceived quality by users. What systems we had been using for some time, rule-based systems, became suddenly quite more useful, more user-friendly, even though they may look archaic nowadays compared to neurals. Then again, statistical systems reached a ceiling of quality, especially when language pairs were distant, such as in English and Japanese. We noticed that very early. We had a 2-year research collaboration with Toshiba in Japan, cracking Japanese English and English Japanese machine translation. At the time, it was word order, one of the most difficult things to resolve in machine translation. And from 2017, with new advances in technology, we became very excited with the advent of neural networks, the possibility to train very rapidly, not in months, but in days or weeks, deep neural networks that allowed us to experiment and to grow much efficient and much deeper machine translation systems. That has led us to a road that not only includes machine translation, but other NLP areas such as anonymization in discovery, for which we have become suppliers technology to banking institutions, large institutions, and companies around the world. In 2021, there are some news that we want to share with you, and is the possibility to grow your own ecosystem on-premise, completely independent, keeping data safe, being fully compliant with GDPR or CCPA in the United States, and cloning and developing engines with a very high degree of, I don't want to call it human parity, but closing the gap with humans. So before we start, I'd like to touch upon a couple of concepts so we all know what we are talking about and what we refer to when we speak about machine translation, about is machine translation part of artificial intelligence, what is machine learning, etc. Well, artificial intelligence, which is the, let's say, is the goal to which we all aspire to, is the science that enables computers to make decisions, to let's say, have an independent brain, so they can offer choices or make choices on our behalf, or at least provide recommendations, selections, in a way that resembles our own behavior. Now, this is not new, really. If you think about it, calculators have been beating humans, so they are well beyond human parity from 1950s. And anybody who's been a schoolboy in the 50s and the 60s and the 70s and so on, we all know that we can't calculate any faster than a calculator. So there are many ways in which technologies has already made us better. Machine learning is a branch of artificial intelligence which focuses on data and improve the accuracy over time, usually with retrainings, and with very little programming. So in machine learning, we would study we would develop computer algorithms that improve the user experience or improve accuracy and precision over time, and with user feedback. Deep learning is a subset of machine translation and is based also on artificial neural networks, and these neural networks develop their own behavior, typically with annotated examples. Deep learning, for deep learning to happen, we need to do what we call training, which we'll see in a little while live. So what is deep adaptive, and how does deep adaptive differ from machine? Is it just a pure machine learning, or a deep learning, an automated deep learning? Well, it's not. We all know what adaptive is. Adaptive has been around for a couple of years, and it seems to work pretty well. Some companies offer auto machine learning. True. Deep adaptive differs because it's user configurable. It empowers users to select how they want their data to impact learning algorithms, to morph the engines so that the resulting engine very closely resembles human choices that a human would make in terminology and mimicking style very, very closely. And this in machine translation means that we go beyond the translation, word by word translation, sequence to sequence, to learn deeply expressions whereby a bunch of words in a language become only one word or two words in another language, even though statistics and the huge amount of data that we use to create basic engines tell the system that the translation should be different. So within minutes, these engines can change, can modify their behavior because of the input data that is being uploaded into them. Deep Adaptive is available from our Echo platform. That is echo.pangeamt.com, and that is where our SaaS system is located. Some companies use it as a SaaS system, some companies use it on premise. So what is the landscape in deep learning? Well, deep learning is a very active field, that is true. There are practically new developments every month, new papers, new academic papers. There's a new frontier being crossed every month, and there is a lot of cross-fertilization between scientific fields. For example, what we learn about image recognition, this picture has a bridge, or this is a cat in a much larger picture, which is quite difficult for a machine to detect because machines only see pixels. Well, that type of image classification or object classification can be exported to machine translation. This is part of what my colleague Mercedes knows much better than me, what is called multimodal pattern recognition, multimodal training. And there are, again, a lot of progresses and different sciences and changes. We have moved from recurrent neural networks to attention models, to self-attention models, in which, for example, a word is segregated into several other words in the target language and likewise. So while I was preparing this presentation, it occurred to me that I was going to present something of which I had already talked about a couple of years ago, back in Athens in an earlier, the sister Gala organization in Europe. This was in Athens. I think it was at spring in Athens, and I discussed the very early days of neural machine translation, where we would be in 2, 3, 5 years time, to a lot of LSPs, and if their business was going to change, the business model was going to be different, if they could afford to ignore neural machine translation, or what they were going to do about it if they plan to integrate it. And I would just like to remind you of some figures that are through to the audience, a very large audience at the time. In our industry, in the translation industry, we've moved from nearly $20 billion in 2005 to $40 billion in 2016. I think is $50 billion according to Common Sense Advisory data. So clearly there's a huge market, a growing market out there. Incidentally, one of the fastest growing stacks in LinkedIn and the US Census shows that the amount of people that class themselves as translator has grown a lot. And I've discussed this with one of LinkedIn executives here in Spain. Translation didn't used to be a job that many people advertised in LinkedIn, but it has grown together with, of course, data scientists and IT personnel. But it's not an occupation. It's not a job that it would come to mind as a profession, a fast-growing profession with a large number of professionals, and it is. So, are they at risk? Should language professionals be worried? Well, in my mind, only those companies that produce machine-like translations and only those people who translate like machines should be worried. Humans have a much higher value, and they can add a much higher value to what they do than repeat sentences or use their gray matter in the brain than to transfer words from one language to another. They can embellish things and they can make decisions for which AI is not ready yet. So really, it's only the lower end, the let's say the manual, the very basic work that really should be feeling at risk from machine translation. For the rest of us, well, I see a lot of new jobs being created. Right now, there is a frenzy, there's a fever on annotation, on producing data to feed AI systems, all types of data, from sentiment analysis, annotation, to annotating sentences for machine translation to improve the name, identity recognition and detection in MT, for anonymization, etc. That will have, as everything, that will run, I'm sure, for a couple of years, but it will surely die a death now, because a lot of systems will have been built. No, there will always be customization. Whatever system is built, new realities will happen in the world, which will require new terminologies, new types of detection, new names to be adopted, and retraining and fine-tuning. So, and there will always be a lot of content that needs to be created, new language pairs, new areas of knowledge that are completely untapped. So are we facing a hype with neural machine translation? Are we thinking that, well, in a couple of years, this is a problem that will be solved, that we will achieve complete human parity and machines will be able to publish everything? For us at Pangeanic, it's a distant goal, but we're working very hard to make that happen, at least in domain, at least in certain areas, to be able to publish content unrevised or with very little human revision. We all know what happened in the 50s with the Georgetown experiments, and scientists saying that, oh, we'll crack Russian in a couple of months, we'll be able to translate the entire corpus of the Russian language into English because we want to know what the Soviet Union is publishing and what the Russians are talking about. That died a death, obviously, with the ALPAC report, which damned machine translation for decades. In fact, it was not an academic area. If you spoke about machine translation academically, it was you became a pariah. It was a no-go area, a problem that could never be solved. Things changed a little bit in AI in the 1990s, when some expert systems came around, and we saw the beginning of automation and really IT becoming part of everyday life, especially for machine translation. From 2009, 2010, statistical machine translation fed hype again. As I mentioned before, we were one of the beginners, one of the selected number of companies that were very early adopters of statistical machine translation. But then after a couple of years, we all realized that statistics had given as much as they could. After 2004, 2005, we had tried most language combinations, and it was what it was. It was working pretty well in close languages, English, Spanish, French, Italian. You could hybridate German, but when languages were pretty distant, like Japanese and English, it was really a challenge. And then became neural machine translation, as we know, in 2017, with neural networks, and wow, off the box, we could get amazing results. All these things that we had been working on and amassing massive amounts of data to feed algorithms suddenly were solved problems, because the neural engine could recognize and reorganize sentences much better. And then the hype started. And within a couple of years, everybody started to claim, we've got parity, we achieved parity, we are close to parity. We don't claim parity as Pangeanic. We have to be careful about that. It can be very good, and perhaps you are lucky and you can have a run of many sentences that are virtually untouchable, and a human will say and swear, oh, this is perfect, go and publish. But you still require some proofreading or human touch at the end, because the devil is always in the detail. When people talk about parity or achieving human parity in a certain language combination, as Microsoft acknowledged in their own paper, this is compared to crowd-sourced or crowd translation services, not with professional translation services. A professional translator, and we do know what we talk about there, because we are in LSP. There is a section of Pangeanic that has been a translation company for quite a while, since 1997 in the UK and 2000 in Spain. Even the best machine translation, a professional translator will change it and will edit it. And if you delve a little bit more into the error category and on how translators found errors in the Microsoft experiment, we still find that the traditional errors remain. Some words have been mistranslated or are missing, even though the sentence reads perfectly well. Some named entities are wrong, or there is one or two grammatical errors. So we've walked the walk as a translation company that wants to change things, wants to adapt and develop technology, and we are aware of the pain that requires, the problem that needs to be solved. For about 10 years, we've been amassing vast amounts of data, huge amounts of training data, initially for statistical machine translation, now also for neural machine translation, cleaning that data, because we know that noise had an impact in SMT. It has even a much deeper effect on neural systems. Neural systems are very sensitive to any noise, any mistranslations, or anything that doesn't render itself well to machine learning. So there's always challenges in system automation, which is what we propose with Deep Adaptive, selecting the right data and having that data very clean. If you have in-domain data and the data that you have is very clean, the results are absolutely incredible. Adding out-of-domain data is only good if you want to tackle very generic engines, but then you will probably lower accuracy of that engine. So when we came to realize all these through years and years of experience, it dawned on us that the solution to a lot of the problems of machine translation specific to many clients were based on terminology and data cleaning and data availability, even though the amount of data was very small. Could we pass the Turing test in machine translation? Are we close to that? Well, Microsoft achieves high 20s in their own experiments, English, Chinese to English. Blurs are very relative. You can achieve a 50%, and that only says that a lot of words happen in the target language that you're translating from. It's just because your blur is higher, it doesn't mean that your machine is much higher. But are we close to what Alan Turing used to predict? A day when machines will be close to human? Well, we don't like to be judged by numbers. As I say, numbers, you can have a 25, you can have a 35, you can have a 50, but at the end of the day is the user experience what matters. If people are happy with the result, well, your blur can be a very meager 23%, but your machine excels. So we judge how good or we are strictly always with human evaluation. I was very happy today, by the way, because one pilot that we're conducting for a South African client, a linguist ran a blind test versus a very popular online translation engine, which he classed blind. He didn't know what he was judging. Sentences were mixed. Sometimes they came from another system, sometimes from our system. So he classed that engine as 91 accurate for the specific domain of this South African client. And the engine that we have built in the field of manufacturing and human resources and management was classed as 97%. 97 is not parity. We're closing the gap. That's all we can claim. I'd like to quote some of our users here, which have benefits from our system. They do claim that on many occasions, the quality produced by deep adaptive is virtually indistinguishable from human translations. And I believe that because we have seen it happen. Our algorithms overemphasize the domain, they farm out data that is not required, so our machines produce less content at a higher quality in generic engines, but produce very good content in specific engines. So, okay, human parity doesn't mean that the translation is flawless. In fact, I have seen terrible mistakes made by humans, terrible translations that were not produced by a machine, but by human. Humans do make mistakes, but our goal here is to close the gap, to be as human as we can in order to help humans produce more and faster content. Another area our clients asked us for a few years ago was the possibility to integrate their system into their infrastructure. Now, that is not easy because training neural networks requires GPUs. GPUs are not cheap. They require certain infrastructure, which also creates some kind of more problems really for your IT personnel. It's more machines to keep temperature for, more machines to run maintenance on, etc. It's more work for them. But we have developed such a system. We have developed and created a flexible infrastructure so that with a viable minimum of GPUs, integration can happen at organizations. Among them, I can mention some clients like Veritone, Spanish tax office, for which we ran a whole translation system in the cloud as a SaaS system. into and out of all EU languages. The governments of Catalonia, Bankia, the fourth bank in Spain, RTD, the Spanish television channel, and Deutsche Welle. Now, these organizations are also quite interested in something that is hitting the market, well, certainly here in Europe, which is anonymization, and the fact that GDPR and CCPA in the States are placing pressure on data producers to keep control of the data and the personal data they release outside. Now, obviously, translation is an issue because you're potentially sending out material which contains personal data. So since the beginning of 2019, we have been working on the MAPA project. We were awarded a very large project by the European Union to create the first multilingual anonymization software, which we're including in our platform. I mentioned the NLP areas that we have been working on apart from machine translation. This is one, named entity recognition, basically tagging entities, which then can be either fed to improve the accuracy of an empty system, but also to detect entities and take them away, so you don't see them at the time of translating, or using the service on a monolingual setting, just anonymizing content and not translation. And here I would like to pass the floor onto my colleague Mercedes, who is going to run a live demo of the system, adapting an engine very quickly and seeing the results. Mercedes?
Can you unmute your microphone, Mercedes?
Now, I think.
Yes, that's fine.
Can you hear me? Okay, so I'm using my browser, right?
Yes, we
okay.
can.
Hello and good morning or afternoon to everyone. My name is Mercedes Garcia, and I'm delighted to see so many attendees and such a strong interest in the next evolution of machine translation and adaptive technologies. Before I begin, I would like to show very briefly how easy it can be to use our set levels of aggressivity in neural machine translation training. Manuel has already explained this in his presentation, so I'm going to demo just one case. We have chosen a basic engine in our system. This engine is a basic version because it has not been trained with certain expressions. And this is a sentence from Spanish into English that we know this engine can translate very well because it's missing vocabulary. So as you can see, the result is a literal translation and it's not correct. In order to fix this problem, I'm going to upload a bilingual translation memory file, which is a TMX file that you can see here, and it contains the correct material in it. This material can be post-edited translations or new material to create a domain-specific engine. For this purpose, I'm going to clone the base model, this one. I'm going to create a new one, naming the model, adding the description, and I click in the clonable or trainable options. And this is a copy of this base model. And now I will train it in a very user-friendly way. So this is the TMX file. Okay, and each level of training has been designed for a particular purpose, from a slow data addition to aggressive in-domain customization. We'll start with 3 levels of deep adaptive, although this is something that is completely configurable. I'm going to choose the aggressive mode because I want to prioritize this material in the machine learning cycle. Okay, so I will leave the engine to train and we will come back to it in a few minutes. Meanwhile, I will continue with the presentation. I think, okay, yes. Okay, so I'm going to introduce our ecosystem architecture, which is based on a neural engine farm in Dockerized versions handled by Kubernetes. Users can freely train their models using GPU that makes the process faster. We use automatic metrics such as perplexity and accuracy that gives you the confidence of the model, blé and terre, that you can compare the translations with a reference, etc. In this way, we are sure that the training has been performed correctly. We end up with a hierarchical architecture based on cloned, customized models. The decoding or machine translation process can be performed with CPU or GPU and can be executed through our ecosystem API or plugins. In the next slide, we compare our 3 levels of aggressivity, and I'm showing Blaise course results of the translation of 3 files. A generic text in blue and 2 files from DGT domain, one in red and one in yellow. DGT stands for the European Commission Directorate General for Translation. We have used DGT test 1 to retrain the generic model. Even though the generic test translation performance decreases when we retrain the model more aggressively, we can see that the domain-specific test files improve their translation performance. Therefore, the model gets better for a specific domain, and the user can choose the level of customization for better results. Now I'm going back to our demo. We have trained the model on, okay. We have trained with the new content very quickly, and the engine have learned that the new stuff has to be prioritized over anything that it had learned before. In short, we override statistics and the algorithms morph the learning rate, so the neural network prefers the new expressions. So I'm going to translate again the same sentence and see the results. I'm choosing the correct languages and the model. And we can see that the translation now is correct. Now, deep adaptive can be used so easily by project managers with tons and tons of data to create specialized in-domain engines, legal, technical, life sciences, etc. Or very, very specifically for one client who may not have a lot of specific terminology, but has a very particular style. Deep adaptive mimics very well what humans do. Now we will finish the webinar with Manuel to close the the session, and we will start with the questions. Okay, so Isabella?
Yeah, thank you, Mercedes. Yeah.
Okay. If you want to share your screen, Manuel.
I can do it. It's okay?
Okay.
Yeah.
Can you share it?
Yes.
Okay.
There you go. Very good.
Excellent.
Mm-hmm.
All right. You guys are up for a few questions, or?
For sure. Yes. Yeah. We've got some time now, so we're ready to take any questions.
Okay.
Yeah. Thank you for listening. And if you have any questions, we can answer them.
Okay, let's see. I have a couple of questions here. First of all, a clarification of what you said, Manuel, when you were talking about integration, empowerment, and privacy. One attendee asks, what do you mean by free, you are the product? I think you were referring to privacy and data, maybe.
Yeah. Well, this is an old saying in marketing and in sales that when something is free, you are the product. When somebody gives you free machine translation or free map location, it's because you are helping that system to improve by placing your content on that panel or that API for that system to learn from you, from that natural language. So it can be processed by somebody else. If you use a free location system, you're also helping that system to improve the destinations and destination that you are using that system for.
Okay. So another question is, what are the connectors to standard CAT and TMS engines?
So we have connectors to Trados. MemoQ has been recently upgraded. We have connectors to MemSource. And we have been requested XDM connectors, but so far those are the three main ones that most people use. Basically, MemoQ is the most demanded. Second will be Trados and then MemSource.
Okay. Questions keep coming in, so I'll keep going. What technology has Pangeanic under the hood? Some commercial engine like Google Auto ML, some open source technology, or did you make your own? Did you develop your own?
Yeah, we used TensorFlow as open source engines, which have been tweaked by Mercedes, chief scientist. So they are customized open source engines.
Okay.
Yes, we build our models. Yes.
Okay, another question. How large are your basic models? Because usually it takes hours, says an attendee, to retrain a model. How come that your retraining happens so quickly?
Models are built on around 18 to 22 million segments. Retraining happens on a GPU server and is highly optimized so that, for example, 100,000 sentences would take no more than half an hour. A very small TMX file, like Mercedes has shown, is in addition to the system. It's not, we're not training 18 million sentences from the beginning. So that amount of training is virtually minutes.
I train only with 8 sentences, so it took like 5 minutes, and it was only a retraining.
Yeah.
And we do it with GPUs. That is so fast.
Yeah.
Okay. Next question. How do you go about ensuring clean data input that goes into the machine translation system?
Okay, so typically for on-premises deployment, it is obviously the clients have to take care the cleaning routine. We do have automated cleaning routines, which can be more or less strict and can help the clients at least deselect what could be noise into the system. Obviously, if you introduce noise into the system, it's going to be replicated in a neural network. We are responsible for cleaning data if we're building a system from scratch. So if we're building a whole engine from 0 to 20 million segments, we will make sure that the data is clean coming from the client. If 500,000 or 1 million gives us. Once the client is gone to a cloud system in SaaS on premises, they're free to add as much data as they want. As Mercedes has shown, you create a clone system, and it's the retraining of that system that takes place. It's quite fast. Then you can specialize each clone system into different areas: life sciences, legal, technical. Each one, there is with time there is a retraining. There is the risk of adding bad data, but not only with Pangeanic, with anybody else. So in short, there are routines to help users clean dirty data. The best thing is that we teach you. There is a little technology transfer here, so you learn what you should not do when you go to auto train an engine.
Mm-hmm. Okay. Mercedes, I need to ask you to mute your microphone because because otherwise it makes an echo, and I see that some people have trouble listening, hearing Manuel. Okay, so other questions. Let's see, where are they? With what languages does it work? So what are the language combinations available now?
Well, neural networks work with any language as long as there is parallel data. This is not, that is a very rule-based system question. Neural net, as long as you have parallel data, you can have a system. Just for information, we have been working for the EU in the NTU projects, and that provides 506 combinations only between European languages. And that's not all of them are English. So you have Portuguese into the other 23 languages, Portuguese into Polish, Portuguese into Bulgarian, Portuguese into Romanian. We have systems working in Japanese, and not all Japanese English. Sometimes it's Japanese into Chinese or other languages, Korean. The point here is the availability of data. If you have parallel data, the system can be trained.
Thank you. I see more questions. So let's see. Can you talk about pricing and what are the main differences between this and, for example, ModernMT? And keeping in mind that ModernMT is adaptive, is GDPR compliant, no trace, a Trados plugin, and in some cases, it's cheaper than even Google and DeepL. So can you talk about pricing?
I'm sure that, well, not publicly here, but it can be very economical, even down to LSP.
Talking about pricing, I will really invite everybody to make a trial. We offer free demo and trial because sometimes it depends on many terms. So we ensure we can negotiate that point. But the real thing is try and check and test and see how it will work with the solution the client need, and for that way it will be negotiable. It's not going to be a problem at all.
Okay, so the attendee who asked that question, you know who you are. You can contact either Virginia or Manuel or Mercedes, and this goes for all attendees, of course. So here we go with another question on quality evaluation. Do you provide quality evaluation in the CAT tool, just like, for example, MTQE in MemSource?
Well, there you go. The quality measurements or the quality tool depends on the CAT tool, not on us. So yes, in principle, yes, as long as the CAT tool supports DFQ or NGM, yes, we support that too.
Okay. And another attendee asks, which languages have the best performance, do you think? Based on your test?
Yeah, we have very good results, amazingly enough, in Japanese. We don't class it as the best, but our Japanese clients are very, very happy after adaptation. And then obviously the most popular languages, the Spanish, the French, the Italian, German, etc. Anything into English works very, very well because obviously English doesn't have a lot of declensions and features that other languages have. But then Chinese ranks, right? Chinese and Russian rank very well too. I'd say those 6.
Mm-hmm. Okay. Let's see. Questions keep coming in, so I'll keep going. Does the MT engine learn fast enough in a live translation when you use it in a cut or with a TM that is updating, or does it always take a few moments to learn?
Yeah, we don't offer on the fly. We have tried on the fly training. The difference, what happens on the fly is that you send every segment second after second, and then retraining happens. So basically you are overutilizing your resources, and one sentence, believe you me, doesn't make a big impact on when you are fronting 18 million segments.
Yeah, I'm not sure if the attendee asked about translation or training. If it's translation, you can see it immediately. You see my demo that you see the translation in the moment.
No, I think it's on the fly training what they're asking, Mercedes.
Oh, okay.
So yeah, it's always much better if you really want some impact to wait for a couple of minutes and upload a TMX file.
Yes, we did also on the fly training, but yes, it goes one by one, and it's better to have more feedback.
Yeah,
it has better performance. Yes.
Yeah. Yeah, the idea is very nice. You know, I'm translating one sentence, 2 sentences, and wow, the machine learns. But really, okay, let's be realistic. You have a huge engine that has been built on 20 million segments, and you're adding 25 words. So, well, okay.
Okay.
It's a little drop of water in the ocean.
Right. So another attendee asks, can you improve the fluency by providing monolingual content?
Mercedes?
For the train, I take it. Can you improve the fluency by providing monolingual content? And I guess this person is saying, can you use monolingual content to train the model and improve the fluency?
Yes, we can use it as well, and we can build, of course, synthetic data and improve our model results. Yes.
Yeah.
Okay. Let's talk about. Let's see. There are some comments. I'm going to skip them for now. You talked about aggressive adaptation, and one attendee asks, can aggressive adaptation have ill effects on the neural engine? Mercedes, do you want to take this?
Yes, the question is if it affects, how it affects in generic.
Yes.
General terms. Well, you saw in my graph that in generic terms, it depends on what you are translating. If you going so far from the domain specific train, it will get a bit worse, the performance, because you are retraining the model with the domain specific files. But you saw in my graph that this decrease is not so big, so you can also translate in general terms. But of course, when you retrain, the purpose is to translate in this specific domain.
Yeah. Let's say Isabella, the generic engine is built on 20 million segments, and it covers many areas of language. But really, you want to specialize this engine in financial, and you add whatever 50,000 segments, 20,000 segments, 100,000 segments. Well, the algorithm will detect what you are adding, and I don't want to disclose exactly how things happen, but people, technical people can imagine that it will realize as well that some other areas of the language are not relevant. So you're not likely to translate Moby Dick or Little Red Riding Hood, and it will promote retraining. So yes, it will read after a couple of retrainings, the engine that you've cloned will not translate very generic novels, for example, or marketing material, but your stuff, wow, then your stuff will come very close to human parity.
Okay, we have time for a couple of more questions. So can you intelligently add terminology training from a term base? So not a basic search and replace in the output, but something that works with, let's say, gender, agreements, conjugation, etc.
I think I didn't quite catch the question, because that is down to the neural network itself, to the attention model. Can you come again, please, Isabella?
Sure. Can you add terminology training from a term base, not a basic search and replace, but something that works with gender agreements and conjugation, or something similar?
Yes, it can be added. Yes, in short, yes, it can be added.
Okay, excellent. Yes. Let's take one final question. Let me skip the comments, which are all very positive, of course. So your recommendation is to make very specific models for various areas of a business within a company. Like maybe one model for every product we make, or one model for product strings and one model for marketing strings. Do you help your customers with this kind of best practices?
Yeah, I wouldn't go as far as building or retraining an engine for a product, not even for a line of products, to be honest. Deep adaptive is very powerful. It's not a simple adaptive that has been around for some time, and it also basks on a lot of data and data sets that it has in the background. So people do combine different domains into one engine. For example, life science into marketing, because they don't have, for reason number one, because they don't have enough data. Number two, because their client is on life sciences and they want just one life sciences. Or rather, I'd say it in a different way. They want an engine for the client, not for the domain. Okay? So they want to specialize the engine as the client speaks, or as the client produces content. So that content can contain some financials, some hydrology. Okay, well, that's a real case scenario, backlines that I've mentioned in the presentation, and they mix banking terminology, hydrology, water rights between Texas and Mexico, and so forth. So that engine is very specialized into what that client translates, which is different domains with a lot of varying terminology. But let's say one style.
Okay. It's 1 minute past 6, so I need to close the webinar, unfortunately. Thank you so much, Virginia, Mercedes, Manuel, and a big thank you to all participants who were so interactive with the panels, with the presenters. You can see there, excuse me, you can see Manuel, Virginia, Mercedes, and Brent emails on the screen. So if you have any further questions, I'm sure they'll be more than happy to reply to you. We would appreciate it if you could just take a minute to give us your feedback on today's session using the post-event survey. And your feedback, as you probably know already, is going to help us to refine our webinar programs. One point of Gala news: there are other webinars scheduled for the next few weeks, and so please check the event section on the Gala website for more information. I think I've said it all, and I'm gonna wish you a good day or a good night, depending on where you are, and I look forward to seeing you at another Gala event, either online or in person, hopefully in the future. Bye, everyone.
Thank you. Bye-bye.
Bye. Bye.